In April 2026, CATL, the world's largest battery manufacturer, announced it had solved the core manufacturing problems standing in the way of a battery technology the industry has been chasing for over a decade: sodium-ion batteries, built from one of the most abundant materials on Earth, are now entering mass production, and the first passenger vehicle carrying one is already built. That vehicle is the Changan Nevo A06, unveiled jointly by CATL and Changan Automobile in February 2026. The companies are calling it the world's first mass-produced passenger EV powered by a sodium-ion battery, and it is expected to reach the market by the middle of this year. To understand why this matters, it helps to understand what sodium-ion batteries actually solve. Lithium, the material every EV battery on the road today depends on, is geographically concentrated, expensive to extract, and its supply chain has been a persistent bottleneck for the entire EV industry. Sodium is different. It is one of the most abundant elements on the planet, found in ordinary salt, and does not carry the same supply chain fragility that lithium does. CATL's chief scientist, Wu Kai, confirmed at the company's Tech Day event on April 21st that four major engineering hurdles had been resolved. These included extreme moisture control during manufacturing, gas generation inside the hard carbon material used in the battery's anode, difficulties bonding aluminum foil components, and the large-scale production of what the company calls self-generating anodes. Across the full development process, CATL says it addressed more than 100 separate engineering challenges to reach this point. The company has invested nearly 10 billion yuan, close to $1.4 billion, into sodium battery research since the program began. The performance numbers are where this becomes relevant to actual drivers, not just battery engineers. CATL's sodium-ion cells currently reach an energy density of around 175 watt-hours per kilogram. That is lower than top-tier lithium batteries today, but CATL's Chief Technology Officer, Gao Huan, says the company aims to close that gap with lithium iron phosphate batteries within 3 years. Once that happens, vehicles using sodium-ion batteries are expected to reach driving ranges of up to 600 kilometers, or roughly 372 miles on a single charge. Cold weather performance is where sodium-ion batteries already outperform lithium. CATL's testing shows these batteries retain around 90% of their capacity at temperatures as low as minus 40 degrees Celsius. Lithium-ion batteries, by comparison, lose a significant portion of their range in freezing conditions, a problem that has affected EV owners in cold climates for years. CATL's Chief Manufacturing Officer, Ni Jun, confirmed the batteries can operate reliably down to minus 20 or even minus 30 degrees Celsius in real-world conditions. Cost is the other major factor driving this shift. CATL projects sodium-ion battery production costs will run about 30% lower than lithium iron phosphate batteries, the most common battery chemistry used in affordable EVs today. Lower cost, combined with a supply chain that does not depend on lithium mining, is why CATL's chairman, Robin Zeng, has projected that sodium-ion technology could eventually capture 30 to 40% of the entire battery market, not as a niche alternative, but as a direct replacement for a meaningful share of vehicles currently running on lithium. The rollout is not limited to passenger cars. In December 2025, CATL announced plans to deploy sodium-ion batteries across 4 separate sectors: battery swapping networks, passenger vehicles, commercial vehicles, and energy storage systems. By early 2026, the company had already launched a light commercial vehicle solution called Tectrans 2, built specifically around this battery chemistry. The scale CATL is already operating at gives this rollout real weight. According to China's EV battery tracking data, CATL installed 29.06 gigawatt-hours of EV batteries in April 2026 alone, giving the company 46.6% of the entire domestic market that month. Of that volume, 19.53 gigawatt-hours came from lithium iron phosphate systems and 9.53 gigawatt-hours from nickel manganese cobalt batteries. Sodium-ion production is being layered on top of that existing lithium manufacturing base, not replacing it overnight, but expanding alongside it. For 2026 specifically, a CATL executive told Bloomberg Television that the company expects between 10,000 and 20,000 electric vehicles to be built using its sodium-ion batteries this year. That is a modest number compared to CATL's overall lithium battery output, but it marks the first time sodium-ion technology has moved from a laboratory concept into vehicles customers can actually buy. CATL is not stopping at sodium. Alongside this rollout, the company's long-term research roadmap is shifting toward an even more advanced chemistry, lithium-air batteries, which use metallic lithium as the negative electrode and atmospheric oxygen itself as the positive reactant. That technology remains in earlier stages of development, but it signals CATL is treating sodium-ion as one step in a longer chain of battery innovation, not a final destination. What this means in practical terms is straightforward. A battery built from one of the most abundant materials on the planet, cheaper to produce, more stable in cold weather, and now installed in a real production vehicle available to customers this year, is no longer a research paper or a future promise. It is a manufacturing line running today, with tens of thousands of vehicles already planned to carry it before the year is out. Whether sodium-ion batteries eventually take the 30 to 40% market share KTL's chairman has projected depends on how quickly energy density closes the gap with lithium and how fast production scales beyond this year's initial rollout. But the core question that stalled this technology for years, whether it could actually be manufactured at scale, has now been answered.